Everyone, and welcome to today's webinar. Again, thank you for joining us for the second part of the Moving Your Course to Modern AMPL faculty workshop. Today will be hands-on as we announced on Tuesday, and the session will be led by Juan and Eduardo, who by now need no introduction. Today's session, as well as being recorded, the live Q&A is also available, so please feel free to send your questions there, and we'll be happy to address them either during the session or at the end of the session. You can also email us at academia@ampl.com and we'll be happy to follow up after the session. With that, I'll turn it over to Juan and Eduardo.
Right, thanks, Ina. Yeah, so said correctly, we are in the part two of this training series. Today is more a hands-on approach. So the idea is for you to follow what I'll be doing, and I'll be sharing the screen. Eduardo will interrupt me every time I messed up. I usually mess up, so be prepared. Having said that, I'm going to share now my screen. All right, if I'm correct, you're seeing now the presentation, and right now you should be seeing bigger. All right, good. So what are we going to do today? Basically, I'll give a brief summary of what mainly Eduardo was presenting on Tuesday that we discussed about. And then we're gonna check a little bit of the setup. So we're gonna check if you have everything installed, if everything's working properly. And then we're gonna go to a live demo where I'll be showing you where I start with a simple basic model, so the diet model by that model. And we're going to transition that to a Python-based workflow, which is the whole point here of the showing you this kind of capabilities that we now have. All right, before we start, before I give the summary, check if you have Python installed and VS Code installed, or if you're going to follow in Colab, it's okay. And also check if you have the academic license activated and if you have your own sample model. I'll be summarizing the first part. So if you have any of these ones checked, feel free to like get going with that, especially with the academic license. Remember, you're with an academy email, and going to the portal is quite easy to actually get. So, all right, let's go to the summary. So what we did in the first part was basically introduce you to this whole new tools or toolkit that we currently have at AMPL. And this is like the summary of what it looks like. So in terms of an editor for your AMPL code, we are moving away in a sense from the legacy IDE. It's still there, but we are no longer supporting it. So we really encourage you to try using the new options. So the new options, we are not giving you an editor, but we are basically giving you an extension for the most common text editor out there, which is VS Code, which is provided by Microsoft. But if you're not using Visual Studio Code, it's okay. You can use your own editor, but we are the only official AMPL extension works in VS Code. But there are plenty community actually extensions in other languages. So there, you will find the syntax highlighting, the debugging kind of features that you already have in the IDE. And basically now you can install AMPL and solvers with a simple, they're managed as a simple Python package. So basically via pip, you can install them and activate your license. And we'll see that in this webinar. And this second group of the things that are in your toolkit, basically, you can run all of the stuff we're going to see in a Jupyter notebook and in Colab directly. So there's a way of not installing anything. Basically, have a web browser, and you can already be running code and be running optimization models with both commercial and open source solvers, because you can activate your license in that environment also. So this allows you first to have a no installation setup. So that's pretty great, especially for beginners in these kind of subjects. And Well, second, you in a notebook you can also add some narrative. You can also add some text. You can also add some math equations, some latex equations. So you can, as a teaching resource, is quite useful. And we hope actually to get your feedback if you're using the afterwards later on. And then we also discussed and we presented some stuff on Tuesday about the MO book, which is this interactive book that teaches optimization and teaches sample. And well, I'm not gonna open it again, uh, but yeah, you can check it out and it's full of resources. We mentioned a little bit about the AMPL bot, which is this LLM assistant that can help you with installation, with support in AMPL. It knows pretty well the AMPL syntax. It will help you run everything smoothly. And yeah, I'll mention a bit more about AMPL in this presentation later on. So the main message here is we want to provide you with more tools, with more alternatives for your teaching process and for your research, actually. We also want to get it closer to what industry is using and is doing. So your students are basically prepared for what they'll probably be facing after they graduate. Uh, but this is not kind of enforcing you to do something. So feel free to use VS Code and extension if you want, or mainly Collab. This is really up to you, and we're happy to support and provide with anything you need. This was also a very important part of what we discussed on Tuesday, which is basically what are the licenses that we provide for academia. Starting with the one we're using today, which is AMPL for Academics. We're using it because it is easier for you to activate that. It's basically a self-serve process. So you enter the portal. I'll give you the link to that one. But if you go here, it will probably redirect you to this same information and from there to the portal. So you get to the portal, you create your account with your academy email, and then you add a bunch of details like when are you graduating or if you're a professor, etc. And within a couple minutes, you will have your UUID, which is the thing that we are looking at because that's the thing we will use to activate your license today. So if you haven't done that yet, I'm still giving you some time. Please go ahead and do it. Then we have Ample for courses. So yeah, if you are a professor, here we have a mix of student professors watching this, but if you're a professor and you're giving a course with Ample, you can apply for Ample for courses. So this will basically include all the commercial solvers I didn't mention, but Ample for academics include the 10 main commercial solvers. There are a couple ones that are not free for academics, so we cannot kind of include them there. But we have the main ones, Rofi, Express, COPT, etc. And Apple for Courses includes every one of them. And it's basically one UUID for the whole course. So you kind of remove the burden on your students of doing this process and simply share the code. This expires. So Apple for Course expires in either 4, 6, or 8 months. So it covers basically typical semester or typical course duration. Ample for Academics doesn't expire, but it requires 12 months of renewal. Well, then, after you graduate, you can also have access to these ones. It's Academic Career Starter. So basically, it's for if you are within 24 months from graduating, you can have access for free to Ample and to all commercial servers for 12 months. We do ask you a company email, but I mean, yeah, a work email. But yeah, it's pretty good thing to kind of get you this ramp up. All right. So last chance, how to activate your Ample for Academics. Really important thing. Basically, go to this link, portal.ample.com. Really, just portal.ample.com, and you can create your account from there. And what I said, simply follow the steps, give the data, give your expected graduation day or your professor title, and you'll be able to see your UUID. I'll use one today. You can copy it, but it will stop working like today. I think I said the expiration date. So yeah. All right. Hopefully all of you guys are up today. Please, Eduardo and Ina, if you see some questions or some raise hands or whatever, let me know.
Yep.
I think I cannot see them right away. So yeah. All right. So we're going to start this demo. What we're going to do is first configure the Visual Studio Code. So for the first part, if you plan to follow from Collab, uh, relax a little bit because I'll configure the VS Code from scratch, basically, almost from scratch, really. All right. So how are we going to do this? We are going to use some commands. And yeah, here is where I'll be drifting off the presentation and going to the VS Code. But first things first, all the resources in this webinar, and you're gonna need some of them are in this GitHub repository. So please go ahead there. I don't know if we can share the link here in Zoom, but anyway, it's quite direct link. So you can go to GitHub /AMPL/modern AMPL. So I'll leave it there a little bit. There you're going to find the presentation, the slides that we did on Tuesday. You're going to find these slides that I'm presenting today. And you're also going to find the diet model, a diet that file, sorry, and a diet.run file that we'll be using today. They're quite easy files, so quite short files. So yeah, we'll also be creating them, especially for the Google app. So yeah, but I highly suggest you to go there. And you're going to find the notebook that I'll be using most importantly. So that one, yeah. All right, if you don't want to use VS Code or don't want to go directly to the GitHub repository to download your notebook, if you kind of access the repository, you can click this link that is in the slides. That link will take you directly to Google Cloud. So both ways, during this webinar, that is going to come a lot. So there are going to be quite a few alternatives to do the same thing. So let me just click here. And I'll show you, sorry. So if I click the link, I'm already kind of logged in and everything with the Google Colab. If you don't want to do that, you can go to the basically the repository. Here you're going to find everything you need. So especially in part 2, you have the slides that I'm talking about. You have the 3 files that I mentioned, and you have also this one. So you can download this file and basically open simple collab.google.com and import that file. That's going to be basically the same thing that going directly here. Okay.
Hey, Juan, I have a question. Can you show
Yeah.
that specific part of for people that are not familiar with GitHub, for example, how do you download the file and then how you upload it to Collab?
All right.
Really?
So yeah. So you can go to collab.google.com. Yeah, that's basically the link. And here it will tell me a lot of things like, yeah, Collab is great. So here probably in English is upload, sorry. I'm based in Colombia, so everything is in Spanish, sorry. And here you can basically add the file. So once you download it, I have it already downloaded. Let me just so I'm simply dropping my file here. Then it will basically upload it and it will open the same thing that I had in the other part. You probably want to go and connect it right now, but yeah. Hopefully that was clear. Basically, you can go here to this notebook. Here you're going to be able to see, but the idea is that you will be able to run it. And in this button, you can download the file. So when you have it download, you can go here and open it in Collab. Or again, if you're already in the repo, you can go to the slides and click on the direct link. Yeah, let me just here, that link basically. All right, so this doesn't show it. So download the PDF and then click on the link. Sorry. All right. That's it. Basically, that's the configuration from the collab. We are going to go to the notebook. But first, for those of you using VS Code and Python, let me just show you how it looks like. So, all right. So you're probably going to have this on another folder, or it's going to ask you to open a folder. So you can basically open any folder you like with the resources, or where you are basically downloading the notebook. That part is more or less standard. So if you haven't this open, just simply go to terminal and select new terminal, and it will open this part here that I'm showing, right? So let me just. So I'm using the terminal that comes within VS Code. You can open a terminal and that's it. So more or less the same path here, but I think it's easier if we use the terminal that's basically embedded in the VS Code interface. Yes? All right. So once you're here, we are going to run several commands. The commands are in the presentation, basically. So I'm going to explain each command and run it alongside with you, basically. All right, so the first command is this one, Python 3. Okay, before that, a simple note here. It depends on your system if it is Python or Python 3 and how you install it. So basically use the one that opens Python. So before running the command, you probably want to check if I do Python and it tells me I couldn't find it, and I do Python 3 and it opens up some Python. So yeah, in my computer it's basically Python 3, but check with your own, and yeah, we can go from there. Okay, now we're going. So what is this command doing? So this is basically for good practice. This is really not necessary, but I highly recommend. This will create a virtual environment, and I won't go deeper into what it is, but it's basically kind of a sub Python installation of some sort. So there we can install some packages, and only in that virtual environment will everything work. So your Python-based installation is not basically tampered. This is for good practice, basically. And what I'm doing here is basically telling, hey, using Python, you're going to manage the module virtualenv and create it in a folder. This is typical notation called .vn. When I hit enter, you're going to see that in the folder you are located, yes, it will create .vn. So good, now you have a virtual environment created. And we're going to activate the virtual environment. So right now it only creates it, but we have to be standing there. So when we install the libraries, we're gonna install it right there. So how to do it is the next command I have here. I better warn, this probably works in Linux and Mac OS. In Windows is a bit different. I'll show the command. I think I have it somewhere, but yeah, it will work more or less the same. All right, so if you're following from a Mac or a Linux computer, this is the command. So source.vm being activate. If you're following from Windows, probably is .vm being scripts activate. So that's the command you're going to run. And both, after you run them, should basically add this little kind of indicator that you are already activated the environment. Yeah, so I don't know. I think there's a question, right?
Yeah. Yeah, there's a question by
Yeah.
Caroline.
All right. So don't. Yeah, I see. I see. This can feel like it's going too fast. So I'll basically suggest that if you feel that, go to the collab. So the collab is just clicking a link, and you are already here. So you don't have to do anything else, right? Anyway, if you want to stick to the IDE, it's okay. We are no longer supporting that, so we are highly encourage you to try these options. But yes, so if that activation of the virtual environment, I think, felt like a little bit too advanced, it's okay. This is going to be recorded, so you can check it a little bit more slowly. Or again, I suggest go to the collab link. The collab link is basically everything you need. So everything we're going to do is going to be runnable here. All right. All right. Hopefully we didn't lose you there. But anyway, this is the most straightforward. So if you're following me and you have the environment activated, we are going to proceed to install AmplePy and some libraries. So that's basically all we have to do. Okay, so to install those libraries, we simply run in Python and pip install and the libraries we want to install. So which libraries are we installing? Basically AmplePy, of course. And I'll also added there some libraries we'll be using through the notebook, which is pandas for data manipulation, matplotlib for data visualization, and hyperkernel basically because I'll be running the notebook in the VS Code, but yeah, that's optional. And OpenPyXL because I'll be showing some functionalities to play with Excel files. But basically, these are pretty standard libraries. If you've used Python before, probably already have most of them installed, or simply need AmplePy. So, all right, when I hit enter, it should print a lot of messages, but it's basically installing the libraries. It's not doing anything else. All right. So collab people, please stay with me. Or I'm gonna go to the collab, but right now you don't have to do anything. Okay, so now we have the libraries installed. We have basically everything already almost in the works, right? So we install AmplePy, but we haven't installed any solver. So the next parts will be to install the solvers, activate your license, your UUID, and check if everything went okay. All right, let's go ahead and install some solvers. We have documentation for like what's the name of each solver, but today we'll be using basically Hives and Groovy. I added Simplex and Express there just for you to see that it's quite easy to install many solvers. So what this command is basically doing is telling, hey, using AmplePy modules, install these solvers. And then I will hit enter. So this may basically be a redundant if you've never used Python before. So again, please, if you feel that, use the collab link and wait for us. We're going to catch you. All right. So I've already installed every solver there. And that's basically it. The next step will be basically to activate our UUID. And this is the part where it was I was so insisting on you to have that by hand. So basically, Python Ample modules activate, and we're going to paste here the UUID. Like I said, I have a UUID specifically for this webinar, so hopefully you have your academic license UUID. I'm showing it because it will die basically today. So, but do not share that, okay? All right, so
I have a
license,
question, Pan, or well, more of a
go.
question, a suggestion. Can you
Got
show
it.
in the portal where do you get your UUID?
Yeah, sure. So if I go to portal.ample.com, you probably this kind of tabs are not going to be shown, but you will have here a licenses and bundles and my licenses. So like I said, here is the one I use in a typical basis. So I won't open that, but this is the one that dies today, I think, or tomorrow. Okay. So if you already activated and requested the license and you received everything by mail, you should be something like this with your academic email, right? And you can click here and it will basically is here in the up part. You can from there copy it. It even provides some instruction of how to activate it if you're on the Colab environment, on the Python environment, which is basically the same thing I'm doing here. We are here in this step with others environment, but I think these are the two we are covering today. So yeah, so basically that's how you can get your UUID. Okay.
Awesome.
All right, so I know I've been kind of running a little bit, but it's because the guys in Collab are not doing anything right now, and because I want to focus on the content, so on the ample transition to Python-based workflow, not in this installation part, because this is basically following some steps, and you do it probably once in a lifetime, maybe twice. So yeah. All right, we're almost there. Well, really, we are already there, but this command is simply to check that everything went smoothly. So it will check what version of AMPL did you install. If everything went okay, here is my version. So it's a version released a couple days ago, actually. And it tells me that my license, the one I activated, expires tomorrow. So yeah, hopefully you're with me. Again, if you're not, it's not a problem because you only need a web browser, so you can go to the collab. Being in the VS Code, we can now install the extensions. This could be done actually before that, but okay. So if you're with me, you should probably see some symbol here. It's like some cubes piling up, and it's the extension, right? So if you go here, you're probably not going to be this kind of clutter view that I have because I use VS Code for other things. But you definitely have a search bar. So in the search bar, we are going to install a couple extensions. The first one I recommend, if this is a new installation VS Code for you, is Python, actually. So Python is an extension to handle Python code, and you should see is provided by Microsoft. So that's the first extension I would suggest. By the way, they're suggested here. The second extension I would suggest is how to install it. Well, basically, you click here, and you're gonna see here install button, right? And you go ahead and install it. It's not going to take that much time, and basically, it's all one click. Then the Jupyter extension, also by Microsoft, it will be useful for you to run notebooks inside VS Code, but if you're using Collab on a web browser, this is not necessary. Again, this is only for VS Code. Please stay with me. And again, install it. So click it, and here you should be installing. And then I'll suggest you, of course, our AMPL extension. So when you search for AMPL, this is what I was referring to. You're going to find a lot of AMPL kind of community-based extensions. The one that is by AMPL Optimization Inc. So as is the one named AMPL Official is the one that you should install. It's the one that we provide and we support, and is provided by us. All right. And here again, you're going to click on the install part, right? And that's it. We basically run through it, but we configure everything in VS Code. And now we can basically run notebooks from Python codes, check for mod files, check for dat files, everything within VS Code. Again, sorry if I went too quickly, but this is, again, just one once in a lifetime thing. All right, let's get started with the notebook and with the basically the files that we're going to work on today. Okay, so I'm going to be running the notebook from the Google, the VS Code interface, but it's the same thing. It's just dark, basically, but it's the same thing. And I can do it in parallel if you want to be running this also. Okay. One last thing here, if you don't see it, if you don't see this in .vm, it probably says select kernel. If that's the case, click on that, and it should suggest the virtual environment we created, and you can select. Oh, sorry. That's also the last thing I wanted to mention there. All right, let's go to the notebook then. First, this is now for my collab people that's been waiting in the dark. In the collab environment, you do have to install AMPL also. So this is the first cell we're going to run. Sorry, this is the one I already connected. All right, let me close this one. So you're going to run that cell. What this will do is basically install AMPL in your environment, your collab environment that's basically somewhere in the servers of Google, I suppose, right? All right. Then what we're going to do, if you were following from the VS Code, you could or could not have run that cell, but we already did the installation, so it didn't do nothing. All right. So now, what are we going to basically do here is activate your license in the notebook space. So this is also for the collab participants, the ones that are following here in this kind of interface. So you'll be importing the libraries and importing this function, especially that is called AMPL notebook. It will create your AMPL object, basically. An important thing here, we're going to tell from this line which solvers are we going to use and which is our license UUID. So again, for the collab people, this is where you use your license UUID. So we basically paste it here. All right. Hope everyone's with me. And we're going to run this. All right. It should run actually quite fast. This is probably, yeah, right. So this is the license using webinar, but all right. Hopefully you already here. So now both VS Code guys that are following me and Collab guys that are following from the web browser should have everything instantiated. I'll go back again here so you can skip this if you're in VS Code. And you can actually do the same thing here for the VS Code part, right? Fine. I'm going to Collab from now on, but basically just for the VS Code guys, you can simply keep running sets, all right? So I'm going to stick here just for the sake of time. So I won't be switching anymore. Okay, so we're going to do the diet problem. So you probably heard of this, you probably use this in your courses. It's a quite a canonical kind of model. Again, basically the goal here is to find the cheapest combination from a fixed set of foods that satisfy nutritional requirements. So you're going to have a couple sets, two exactly, which is the set of nutrients you want to have in your diet and the set of foods from which you can choose, basically. Those are going to be your sets. Which parameters do you have in this problem? Well, the cost for each food, the minimum and maximum units of each food available, and the minimum and maximum requirement or allowance of each nutrient. And then again, of course, you're going to have the amount of nutrient in each food. So I don't want to stick a lot in this model, but if you have any doubts about the model, please tell me. I can basically stop a little bit here. So, okay, so what's your decision variables? So basically how many units of each food to purchase to fulfill your diet requirements in the cheapest way possible. So the cheapest way possible, meaning we are going to minimize the cost, the total cost of the diet. Yeah, if you are looking at this, right, it's because this has something to do with these spaces. I don't know what it is that, but okay. If you remove those spaces, you should be looking at the equations. All right. So what are the constraints? Basically, minimum and maximum requirements of nutrients and a minimum and maximum basically food availability, let's say, or maximum units of each food, right? So it's a pretty straightforward model. And we're going to create actually that mod file for this one right here. Okay, so in the first session, we saw a magic command here for the notebooks that was ample eval that would basically eval some Python code. Here I'm showing another one, which is write file. So what this will do, unsurprisingly, is create or write a new file called diet.mode. So everything that goes here in this cell is going to be stored in a new file. And what's in the cell, basically the ample code for the model I've just described. So you're going to have a couple sets. You're going to have your parameters with their basically limits, let's say. You're going to have your variables. In this case, I already defined it as an integer variable, so you can only pick complete units of food, but this could be continuous, really. And we have an objective function, which is minimizing the total cost. Everything, your basic ample syntax. I won't explain it because I assume you already know. But again, if you want me to stop here and explain some of it, please do. And you have your restriction with the minimum requirement and maximum allowance of the nutrients. So far, so good. If I run this, you will see here in this little folder that you have now the diet mode created. This is exactly the same file we provided in the rep. So no worries about it. If there's any doubts, please let me know. Otherwise, I'll keep going. And I'm going to show you basically the other two files. That file, which is a typical .dat file that will be moving to pandas to Python. And I'm going to show you the run file. So the run file is basically our AMPL scripting, but everything was controlled. What we're going to do here is we're going to see each line of this run file be converted into the Python code. So that way you can see each part of what you were doing previously in the AMPL IDE with AMPL code, like this one, how it translates or how you can do the same thing with AMPL, all right? So let's start with that file. So I'm basically here have the cost and the minimum and maximum amount for each food, which is this is the set of foods. I have the minimum maximum allowance and requirement from nutrients, which are these vitamins A, C, B1, B2, sodium, calories, I think, or calcium. I don't know what is that. Some nutrients. All right. And the amount of that nutrient into each food. All right. So we're going to create that in Python. All right. So here we are going to see that we are basically creating the same data. So I'm telling it which is the food, which is the set of food, how much is the cost, how many is the minimum and maximum requirements of each one of those foods. And I'm basically adding it to a data frame. If you've used Python before, this should be, or pandas before, this should be pretty basic. If not, just know that I'm using a data structure to create this exact table. All right. All right. The same goes for the nutrient data and from the amount of each nutrient in each food data. All right. So I don't want to go deep into the workings of pandas. That's not the purpose here, because anyway, this could come from an API. This could come from actually Excel files with the table data that you read. This could come from any place, basically. That's part of the point of doing this with Python, basically. At the end of the webinar, I'm going to give a way of creating CSV files or Excel files from a previously loaded data. And also concerning a question in the first part, I'm going to give basically a way of creating the .dat file, if you need it, from a previously loaded AMPL model, okay? So yeah, basically, for now, trust me that this will create the data frames we will need. But again, this could come from anywhere, and I'm going to teach you how to create some CSV files, some Excel files from a .dat file, right? I hope so far so good. I don't know if there's any additional questions right now. If not, we are basically now able to reproduce the run file. So remember, I'm going to show you again. So remember this file, we're going to reproduce that in Python. That's what we're going to do, okay? So the run file start with a reset. This is basically a good practice, I think, is sanity to have your model reset, especially if you're going to be running multiple times these kind of things. It is very basically to reset. How do you reset? Well, quite intuitively, you take your AMPL object and select AMPL.reset. And that's basically it, right? So far, not really that surprising. Basically, directly parse from one syntax to another. The next line of the run file was basically loading the model. In here, we're using a function that is the read function. So we're going to read that mod file. Okay, so remember that I told you that this cell here would write the file. So we have the file created here, and that's why we will read diet mode, because it will read exactly that file, okay? Just for you to know, this read command does not only read specifically mod files, it reads any text file with AMPL code. So we'll see later on a special feature that is called the Dutch feature that we can use from this, but that will be later on. All right. Good. Right here we have parsed the model diet.mode. Now it comes with the data diet.dat. So here are many ways of doing this. I'm just showing the one that using the data frames that we created. So these data frames, and you can actually check them. In fact, let's check them. So let's see one of them. So let's see the DF food data frame. So if I basically print it here, right, I'm going to see that this is the data frame. So this is the data we created. So I'm taking advantage of this data frame and loading it into the AMPL model, okay? So what AMPL will do is basically look at the columns of these data frames, and based on the name, is going to assign those values to that parameter. So these names of the columns have to coincide with the name of the parameters we define in the diet.mode. So if you can see here, we define a parameter cost, a parameter f min, and a parameter f max. So since the columns coincide and the index of the data frame is actually the set for which it is indexed, so food index, I can basically load directly the data frame and tell it, okay, the index defines the food set. This is what I'm doing here. And it's not the only way to do this. It's quite versatile language. So I could basically define the set separately and then load the parameter. It will also work. I'm here providing just one way and invite you to check the documentation to check everything that fits better into your flow, basically, right? Okay, so the same goes for the other two data frames. And basically, with this one, we are using the data frames created to load data. If you are working with a .dat file, which is, again, your choice, there's a function to read the data, and it's basically read data. I think I mentioned it in the notebook. All right, I'm going to show it right here. So if you have a .dat file, which is the case here, if you have this file, and let me just upload it to the notebook just for this to run, you can have a read data and basically tell it the name. So diet.dat. Right. So what this command will do is basically load the model. So it is the direct translation of using a .dat file. Okay. Again, this is not what I'm trying to show here, but if you want to use the .dat file, you can use this one, and that will replace basically all of this. In fact, let me just copy right here in a comment. So these are two versions of the same thing, okay? All right. The next thing in our run file was basically defining which solver we plan to use, then solving it, and then showing the result. So for selection of the solver, we simply, again, the syntax is quite similar, so that's why this transition should feel kind of easy on you. So basically, we're saying that the option that's called solver is going to be highest. Once again, it's not the only way to do this. I'm going to provide you with another one. For example, you could use the set option method, and you're going to say, okay, the option solver, I'm going to add highest as a solver. This is another way of doing it. Again, this is to show just the versatility of the API syntax. You can choose every way you want. After selecting the solver, well, we are able to solve. I can run the cell, and there we go. So just to recap, what have we done here? We basically translated every line of this run file, pretty basic run file, to Python. So we show how to reset it, how to read the model, how to load the data in a couple ways, how to set the solver, how to solve, right? We are missing the part of showing the result because I want to do more than just showing the result. So let's go ahead. Please interrupt and please ask any questions you may have, all right? All right, so to get the results, I could simply actually call AMPL display, and that would be it. But I want to basically get the results and do something with those results. So it's basically, this is what I will do. So the first thing I do here is getting the objective. How much does the optimal diet costs, and then I'm going to get the variables and translate into a pandas object. So this is one way of doing this. So I'm getting the variable by, which is the one we define, and basically translating its values to a pandas data frame. Well, if I run this, you're going to see the first part, basically getting the objective. You input the name of the objective and ask for the value. It's really direct as that. Is going to print this one. Optimal diet cost, and that cost is 119, let's say, dollars. Okay, and this is the data frame that we created, basically the solution of our problem. Okay. All right, so I can get a lot of information, not only the solution and not only the objective. I can get actually, for instance, information about the constraints, information about duality, if this were a linear problem. But in the sake of time, I think I'm going to briefly mention it. I'm not going to deep dive, but basically there's a function called getData that receives in Python in AMPL code whatever you want to get. So if you want to get the lower bound, the body, and the upper bound of the restriction of the constraint, the diet constraint, it will be as simple as calling this and calling this to a Panda data frame. So I already will have this data for manipulation, right? So I can see which constraints are active, or well, I can analyze the model in any way I like, all right? So using this data frame, these results, we can also visualize it, and that was what I saw the Matplotlib did. So I won't go deeper into the plotting kind of code. It's a simple plot, but basically I just create here a visualization of the solution of my problem. So I'm here watching. We are seeing here how many units of each food to buy in the optimal diet. So as you can see, it's quite easy basically to extract information, to extract the solution, and to present the results. It was quite direct, right? Now we're going to go briefly about some things that are basically how to change parameters after I have already solved. So how can we do some sensitivity analysis? How can we get actually the duals? That's all in this notebook. Again, I'm probably going to up a little bit the rhythm here, just to leave room for questions in the end. All right. Okay, so here we're going to evaluate what happens if the cost of beef, which is this one, that the optimal solution for the base model was 9 units of beef. What happened if it broke it? And it's now the original value was like $3 and now it's 10. So here I'm showing just another way of updating data. So we're going to get the parameter cost, specifically the cost of beef, and we're going to set it to 10. And then result. That's everything we have to do. And then we're basically going to get the solution. I'm showing different ways of doing it, just for you to have different tools to do that. And we're going to print the new solution. So if I run this, I get this new basically optimal solution. Now we're not getting 9 units, but we're getting 6 units. And with this, and with some Python scripting, if you're familiar with Python, you can basically create in the most basic form a for loop, basically, and change the value of the price to of beef and check the results and do some manual sensitivity analysis if you like to.
Hey Juan, I
But
think we have two questions in the
go.
Q&A. They are
Yeah,
quite
please.
interesting, so I think maybe we should look into them.
All right.
First, we have a question by Maria. She's asking how to use only VS Code plus AMPL extension without Colab to run a file. So I think we have already that setup. If you can just
Yeah,
show
all
how
right.
it looks like
So
in VS Code.
you basically want to run that run files, right? So you don't want to create all this Python scripting. So that's gonna work with just the read command, right? So if you are here, by the way, I'm doing this in notebooks, but this works exactly the same if you're working in a Python basic script. So that py could also work. Okay. Okay, so let me do that here. I think I did activate the license, so I haven't done anything in this notebook in the VS Code, but activating the license, all right? But so if I go and simply set ample.read, I have the diet run file right here. If I do that, I think that this is the question, and please correct me if I'm answering something that wasn't asked, okay? But if I run this, it will basically read this code, and this code will run ample. And so it will load the model, it will load the data, it will select hi as a solver, it will solve and display the value. So that's basically it. So what happened under the hood was basically it selected, it loaded the model, loaded the data, selected highs as a solver, used highs as a solver, and then displayed the value, right? Hopefully that answered your questions about that one, right? Uh, all right, so how can you debug the mod file? Okay, so if you open this should be already kind of highlighted. Uh, I'd say you can here, there should be additional tools for Ample, so you can run this file from here. You probably highlight the error. You also can debug the Python code actually, and it will basically tell you the same thing. Yeah, there are additional tools that were in the IDE. So this kind of display entity or the entity definition kind of thing that I think it wasn't available in the IDE. All right, so how can we see solver logs using AMPL? So there are a couple options for that. I think Eduardo was answering, but basically just as we defined the highs as an option, yes, you can also use some specific options there. So there are options for outlet, which is basically printing there the log, not only this brief message, but the whole log. And you can also actually throw that log into a file if you want to further process it.
Yeah, actually, if you go to the diet.run file
Yep.
and you click on the top right, the execute button, the run button, yeah, that should exactly, yeah, that should open a the ample session that will log
Yeah,
the models. Yep.
it's just this file because highs, I only install highs through the library, so it's in a different folder, but it basically is running the file. But again, if you face this issue, I basically suggest just create a small script with this one, and you will have basically everything running, right?
Yeah.
But also, I'm here with an ample session. So here, this ample thing, I can run different ample codes. So this is like the ample terminal, the ample console kind of thing. All right. All right. So I'll skip a little bit the next part just to show you some other things. But in the notebook, and this material is available to you, you can find basically how to change the result. This we already did, and how to treat infeasibility in some models. So here, I basically changed some data for the model to be infeasible. I changed the solver to Groovy, so one line, and I've already changed the solver. And since you're using Academy, you have Groovy or any other solver for free. This will basically tell me it's an infeasible problem, and I will run the IIS function of Groovy. So again, sorry for not going over this, but we are short on time. But it is on the notebook, and if you have further questions, we are happy to take them like for the mail. All right. We also have something about showing how to get the duals of the constraints. So basically, for that, I relaxed the integrality constraint just for it to be a linear problem, a linear convex problem, and I show you here how to get the actual dual value, right? What I wanted to go about was these functionalities because I think we have received some questions regarding this specifically. So I'm going to show you how to create a CSV or Excel files from the DAT file and vice versa. So I'm also going to show you how to create the DAT file from an already loaded model. And I'm going to show you in the process the snapshot feature, and I'll briefly mention the AMPL just for advanced research. All right. So uh, getting from that to CSV, we basically use the read data thing that I told you about. So that's how you load the data file. And then we're simply here. The function is a little bit doing a little bit more things. It's just thought to be a useful function for you. So if you select an Excel file, it would create just one Excel file with everything, with the sets, the parameters. If you select a CSV file, it would create a folder with different CSV files. This is why this function is doing some things. But the important thing here is if you have a DAT file and you want to create Excel files, you can use this function. And what it does is reading the model, reading the data. I'll highlight only the important parts. Looping over all the sets in the model without knowing the name of the sets. So this is also something you can do. So basically, AMPL that get sets will get me all the sets in the model. I don't know anything about this model and this function. I know it will work. All right. And then I'm basically printing every set that I'm looping over. And the same goes with parameters. I'm sorry to have to do this so fast, but that's the way basically to export uh, data in Excel file or CSV file, loading that file, right? Again, sorry for having to do this that fast. The snapshot feature I mentioned a couple times, basically will store your model declaration, your data declaration, and your options, everything you configure, and also some results, so sub result and that kind of stuff, in just one single file. This would be quite useful, especially in teaching. If you're, for instance, doing an assignment or a big assignment, you can ask your students to basically give you the snapshot file and you can see everything like the complete AMPL session. And how to do that is basically calling AMPL.snapshot. And to read that again is the read file, is the read function, sorry. And just I mentioned here that you can create the DAT file using this snapshot function. And how would you do that? That's what I'm going to show here. So in this one, the one I'm highlighting, I'm basically doing a snapshot, but I'm telling don't export the model declaration and don't export the options. So only export the data. After you do that, you're going to see a file that is similar to a DAT file. All right, so let me try to run this. All right. So you're going to see a file that is similar to a DAT file. Not exactly the same, but it will work as a DAT file. So it can be loaded into other AMPL, into AMPL as a DAT file. There's a wrapper around this the exact same thing that happens in the snapshot will happen if you just call this export data function. So it's easier that way. And if you want definitely something really close to the DAT format, exactly like how you will look like, how it will look like, you can use basically a combination of displaying the sets and the parameters and printing the param word is the only thing there. I won't go deep into this one. It's there in the notebook if you want to try it. But if you want exactly that format, again, you don't need it because even though it will look a little bit different than an explicit DAT file, it will work exactly as a DAT file. All right. Yeah, I'll leave the ample list for you to look out just to basically go over your answers, your questions. Sorry, answer every questions. I don't know, Edu, we have any additional questions?
Without, but I'd like to share very briefly the how to actually run stuff in VS Code using only ROM files. So for example, this is my VS Code. You should be able to see it now. This is the diet problem. We have the model file and the data files and the run file. So for example, if I want to run this within VS Code, I can just click on this, obviously assuming I have already the AMPL extension installed, the official AMPL one. So now this will create an AMPL session and include the files. And now within the session, I can, for example, I can change the solver to Groovy, and then I can just solve again. Yep. And I'll get the same solution. So this is how do you actually work. If it's okay if you don't want to work with AmplePy and Python code, but we do recommend still that you make the transition to VS Code. And if you do, and you don't want to use Python, this is how do you run stuff with AMPL and the VS Code AMPL extension.
All right. Yeah, so basically, mine failed, but it was basically using the right click, right? I want to show just one last thing. Is basically the result of this creation of the data files. So the first one here, just for reference, you will have the original data file, all right? And I'm going to show what you can create basically from a previously loaded model if you want to do that. Basically, the snapshot or the export data will create something like this. So if you see, this is not exactly the same as the dot file, but this will work exactly the same as a dot file. So it's not the exact format and the exact syntax, maybe. Well, the syntax it is, but basically here is within single quotes. You're going to have every parameter basically printed separately and not in a table. That will be the main differences here, okay? So that will be the result of these two. And if you want to basically a pretty similar one, we will have this diet data export. So if you see, this file was created with these commands, with display and printing the parameter. So how this works is you display the information, so you display the sets, then you print the parameter, and then you display the parameters. And it's exactly what's doing here. So as you can see, you can create a pretty similar dot file if you want that, or you can simply use a single call in a function and both will work, right? That was the last thing I wanted to share. Uh, I'm really sorry I had to run a little bit there. We can do a pretty slow-paced version of this webinar if you find it useful. In the presentation, you're going to find links to several versions of our AMPL bot in several LLM providers. Well, here is our mails. Please write any questions you may have. I know this had to be kind of rushed, but yeah.
Thank you very much, Juan. We'll give you a minute to catch your breath there. It was a long presentation, of course, but really helpful, I'm sure, to our viewers. There's a question in the chat as well that we can address in terms of using cursor instead of VS Code. Is that a possibility? Eduardo or Juan, would you like to take that live?
Yeah, definitely. I think that you can use cursor. Obviously, for those that are not aware, cursor is just another version of VS Code. You could say this. It's a fork that has built-in AI integrations, right? The idea is that since it's a fork, it's VS Code under the hood. You can use the AMPL extension within Cursor. And there are other forks of Visual Studio Code as well. No, Cursor is one of them, but there are many out there. And in theory, the extension should work as well. If it doesn't, please let us know via email and we'll take a look at it. But in theory, it should work in Cursor and any other VS Code fork.
Thank you, Eduardo. Philippe, I see your hand up, so I'm going to open up the mic if you'd like to speak. I think you're muted if you're trying to speak, or otherwise feel free to type in maybe that was a mistake, the raised hand. Okay, well, oh, okay, no problem. Yep. So all is well. Okay. So for now, we would like to wrap up for today. Thanks again to Juan and Eduardo. As we mentioned, today was a little bit of a compressed session. So if there is any follow-up questions, feel free to reach out to us via email regarding this particular session. We also welcome any feedback you have around what you've heard over the last couple of days, as well as any feedback or suggestions you might have about future webinars related to teaching with AMPL or doing research with AMPL and the new modern stack in future iterations. We'd love to have your insights, and we'll be able to come up with topics that are of interest and relevant to you. So feel free to, again, email us at academia@ampl.com. with your feedback, your questions, your thoughts, and of course, anytime you need support, we're there and happy to provide you with the support that you need. Once again, thank you so much to our panelists, and we look forward to future sessions with you. Have a great rest of your day, everyone. Thank you.